Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Naim bin Muhammad Zulhasmi. My number matric is DF220211. We are from Group 4. We'll be presenting of our group project from subject Static and Dynamic. We will start off from introduction first. Static and dynamics concepts are fundamental to mechanics and engineering. Static is the study of system in equilibrium where there is no motion or change, analyzing the force and moment acting on stationary object to determine the effect on the structure. In contrast, dynamics is concerned with moving or transforming system. It analyzes the behavior of object over time and predicts their response to external force by taking acceleration and velocity into consideration. Static and dynamic analysis are indispensable in fields such as structural engineering, robotics, and control system, as they enable the design of stable structure and comprehension of the object motion and behavior.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Fida bin Asha Ali and my metric number is AF220028. I'm going to tell about the problem statement. Each group has to find 5 different types of civil engineering structure. For each example of the structure, the students are required to introduce the structure, picture, material, function, and location. The recording should be made during the site visit. Draw the free body diagram FBD of the structure. Approximate the actions loadings on the structure. Describe the support reaction of the structure, pin, roller, or fixed. Describe the center of the structure. Describe the moment of inertia of the structure and the conclusion. Alright, my test is beam structure. This is the beam structure that I found located at the Block J, College Kediaman 2, Campus Perwira. Beam structure. A beam is structural component that can withstand load by resisting bending. Beams are traditionally description of building or civil engineering structural components. A beam that is fixed at both ends is called a fixed beam. Fixed beams are not allowed the vertical movement or rotation of the beam. Fixed beams are only under the shear force and are generally used in the trusses and like other structures. And this is the free body diagram for the beam structure. As you can see, I assume the load for each is 20 kilonewton meter. And this is the RAX, RBX, RAY, and RBY. After I calculate all of it, I found that support and reaction for the beam structure RAY and RBY both are 60 kilonewton. And this is the free body diagram after I found all of it. This is the centroid for the beam structure. X is 3 meter, Y is 0.25 meter. And this is the moment of inertia for the beam structure. X axis 0.02625 meter power of 4. Y axis is 9 meter power of 4. The conclusion for the beam structure. Based on the estimate calculation that has been made, we can consider that the structure is strong and stable. The material that has been used for the structure is suitable for housing design and it is cement. It is also a very common design and easy to build even though the size of it is big. The support reaction central and moment of inertia have been calculated and the values for all of it are logical according to estimation and reasonable. Finally, in designing a big or small structure, we must be smart and careful in deciding material, size, strength, and durability because all of these are important to make sure that the structure is strong and safe for human use in a long time. Thank you.
The choices of my structure is roof trusses. I have visited the roof trusses that I found is located at parking near College Kediaman Perwira. Roof trusses. A roof is the upper part of building that provides essential support and protection. It is constructed on a framework consisting of trusses, beam, and rafters, forming the foundation for the roof. The type of roofing structure is determined by factors such as building type, desired roof covering, architecture style, and material weight. The building codes play a vital role in ensuring the appropriate roof structure is chosen, meeting safety standard and regulatory requirement. This is the free body diagram of roof trusses. There is two support reaction that can be assumed, which is A is pin and B is roller. There is three reaction support. The assuming weight is 500 Newton of each joint, and resulting the reaction support at AY and BY is the same, which is 1250 Newton, and for the AX is equal to 0. This is free body diagram trusses for centroid and moment inertia. The centroid for x-axis is 3.39 meter and for y-axis is 3.26 meter. Next, moment of inertia of roof trusses for x-axis is 87.9 meter power of 4 and for y-axis is 78.01 meter power of 4. We can conclude for the roof structure, the parking lot near Perwira Residential College has a truss structure exit roof, which is designed using engineering calculation involving triangles for strength and support. Triangles are the key to the trusses design. They are strong and can handle different weight and pressures, ensuring stability and safety. The truss structure evenly distributes the weight of the roof to the outer walls or columns, providing solid support and preventing any concentrated stress point. Trusses are commonly used in engineering and architecture because of their ability to handle various loads efficiently. They consist of straight members connected of specific point, forming a series of interconnect triangles for strong and reliable structure.
My name is Muhammad Nazir bin Kamaruddin. My metric number is CF220044, and today I would like to talk about my project structure. So my structure that I choose is bridge. The bridge was located at E15 University Tun Hussein Malaysia. The bridge was built by concrete. So the bridge in civil engineering span rivers, valleys, roadways, and railroads. It helps transport infrastructure cross impossible terrain. Bridge safely transfer loads to the ground or supporting structure. Beam bridge, arc bridge, cable stayed bridge, truss bridge, and cantilever bridge are common bridge type. Span length, site condition, money, and aesthetic dedicate the bridge type. Civil engineering carefully analyze and design the bridge for safety and navigation. So this is the free body diagram for the bridge. After the calculation, I receive support and reaction for the bridge. VB equals to 150. So for the centroid and moment of inertia of the bridge, after the calculation, the centroid for the bridge is x equals to 3 meter and y equal to 1.5 meter. For the moment of inertia, Ix equal to 13.5 meter and iy equal to 54 meter. So conclusion for the bridge. In conclusion, bridge are essential components of our transportation infrastructure, facilitating connectivity and economic development. Bridge continue to serve as symbol of ingenuity, connecting communities and shaping our world through innovative engineering, meticulous design, and conscientious maintenance. After the support reaction, centroid and moment of inertia has been calculated, all ETHM students are safe to traverse and use the bridge.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Farhan Depozi. My metric number is DF220069 and my part is staircase. As you know, staircase structure is a construction element designed to enable vertical movement between different levels in a building. They come in various design, material, and styles. They can be categorized into different types such as straight, L-shape, U-shape, spiral, curve, and floating stairs, each with its own advantage. Ultimately, staircase combine functionality and design, offering vertical circulation while adding visual appeal to the surrounding spaces. Okay, next I will explain about the function of staircase. Firstly, staircase provide a safe and efficient means of vertical circulation within a building or space. Secondly, staircase allow individuals to move easily and securely between different levels, whether it's ascending or descending. And last but not least, staircase play a vital role in emergency evacuation if any danger happen. Okay, here are the chosen staircase structure for our project. An illustration of a staircase from the residential College Perwira was utilized as an example, representing the connection between various floors such as the ground floor to the first floor to the second floor, and so forth. For the purpose of reference, the density of the reinforced concrete was assumed to be 2,500 kg per meter cube, although it typically ranged from 2,500 to 2,600 kg per meter cube. The specific attribute of this staircase include a stringer height of 1.63 meter, a total run of 2.14 meter, a rise of 0.18 meter, a tread of 0.25 meter, a step length of 2.3 meter, a waist slab thickness of 0.15 meter, a total of 10 riser and 8 step. As you can see here, the idealized and free body diagram of the chosen staircase structure. Here the calculation for this staircase structure. The volume of total concrete is 0.0518 meter cube. The total volume for 8 step is 0.414 meter cube. The horizontal length of base slab is 2 meter. The height of the top of the landing from floor is 1.8 meter. Okay, next, the incline length of base slab is 2.69 meter. The volume of concrete for base slab is 0.726 meter cube. The total volume of concrete is 2,850 kilogram. The rebar mass is 427.5 kilogram, and the RC is 1,300.2.5 Newton. And the moment is to the left positive is 5.80 Newton meter. After conducting the estimate calculation, it can be concluded that the structure exhibits strength and stability. The chosen material for this construction is appropriate for building design. Lastly, it is crucial to exercise intelligence and caution when determining the material size, strength, and durability of structure. All of these factors are vital in ensuring long-term strength and safety for human utilization.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Anas Ahmed Farah. My matric number is BF220019. I would like to present the column structure of my group project. So a column refers to a vertical structural element that is designed to bear and transfer loads from the superstructure, such as beams, slabs, or walls to the foundation or the ground. Columns are typically made of materials such as reinforced concrete, steel, or timber, depending on the design requirements and structural consideration. Columns are crucial components of building and other structures. They provide support and stability. They will help you distribute the weight of the structure vertically, ensuring that the loads are transmitted safely to the ground. Columns are designed based on the anticipated loads they will carry, including the weight of the structure itself, as well as the live loads, example occupancies, furniture, and environmental factors such as wind or earthquakes. Introduction of the case study. As you can see, this is the picture of the front entrance of Africa building. This structure is a slab roof supported by a fixed concrete column. The slab roof is made of highly weavable reinforced concrete. The dynamic load transportation of the structure is that the fixed support of the column will receive loads from the beam and the roof slab. Then it's transferred the load is to the substructures. In this case, this fixed support only resists in vertical reinforce in an opposite direction. So this is the free body diagram of the column structure. As you can see from the picture, the structure is a cantilever beam supported by a fixed support column. Since there is no movement, the structure of the moment is equal to 0. That's why RB is equal to 5 kilonewton, and the submission of forces in y direction is equal to 0. So RA is equal to 15 kilonewton, as well as the submission of force in x axis is equal to 0. So HA is equal to 0. You can see this is the centroid of the column structure. So there is a cantilever beam supported by a fixed column based on the structure. Based on the picture, the height of the column is 6 meter with a diameter of 0.4 meter, and the length of the beam is 4 meters with a height of 0.5 meter. After calculation, the x value is 2 meter and the y value is 4.48 meter. This is the moment of inertia based on the calculation. The value of Ixx is equal to 18.77 meter power 4 and Iyy is equal to 2.702 meter power 4. In conclusion, a fixed support is the most rigid type of support or connection. It constrains the member in all translations and rotations. It cannot move or rotate in any direction. The easiest example of a fixed support will be a ball or column in concrete. The ball cannot twist, rotate, or displace. It is basically restricted in all its movements at this connection.